Okay, well, good afternoon all. Welcome to the Renewable Energy and Sustainability Systems Seminar. I will turn the floor over to our host for today. If you'd like to introduce yourself and then introduce our speaker.
Thanks, Dan. My name is Mark Staub. I'm a student in the Renewable Energy and Sustainability Systems program. And today we are lucky to be joined by Jim Hanna from Philadelphia. He's attending a conference, but the presentation today is Powering the Fourth Industrial Revolution. Jim is currently the Director of Data Center Sustainability for Microsoft. Jim received his degree in environmental science from Washington State University. And prior to working for Microsoft, Jim was the Director of Environmental Affairs for Starbucks Coffee Company. Currently, Jim's focused on developing an end-to-end sustainability strategy for Microsoft's cloud computing infrastructure. And this position is brand new to Microsoft and represents the first time the company has embedded sustainability leadership directly into a primary business unit in the company. So I'd like to thank Jim for joining us today and turn it over to him.
Thanks, Mark. I appreciate it. And I'm still in Seattle, unfortunately, but I will be in Philadelphia later this week.
Oh, okay.
And if any of you are attending the Net Impact Conference in Philadelphia, I'd love to grab a beer or something and continue this conversation. But yeah, I mean, my plan is to really give an overview of what we call the Fourth Industrial Revolution at Microsoft, and it should be a pretty familiar term to folks in the industry and yourselves. But how we define it, and then our what we see as our critical role in playing that process. So, as Mark mentioned, I'm not a tech guy, and I came from the retail industry and spent 10 years at Starbucks, really leading that company's sustainability initiatives. And frankly, one of the benefits that Microsoft saw in hiring me away from the retail industry and bringing me into this role was an ability to translate, I would say, pretty complex stuff into an audience in a language that resonated with a bigger audience. I would say one of the biggest challenges we have in the tech industry as far as sustainability leadership is not necessarily the work we do, but the ability for that work to resonate outside of our industry. So I'll touch a bit on that, but I really want to dive into our role in the Fourth Industrial Revolution. Sorry, I'm trying to advance my slide. It's just hanging up on me. So, again, I think we're pretty familiar with this term, but the way we define it at Microsoft is this industrial revolution that is now in its fourth phase, and it both takes on the physical aspects, and we're all seeing amazing autonomous vehicles, robotics, and 3D printing, and revolution in materials, and also some significant medical and biological revolutions moving forward. And in our space, the digital Internet of Things, cloud computing, which I'm going to talk about today, blockchain computing, localized, and totally disruptive business models that frankly we're trying to feed and we're very excited about as well. We also take the responsibility very seriously in that, as you look back on the previous three industrial revolutions, whether it be the advent of steam or the advent of electricity, which created step changes in the way the world operates, if we all look back on those, we all say there are probably some things we would have done a little differently as we built that infrastructure for those industrial revolutions. And the benefit I think we have today is we're able to evaluate in process this new revolution and look at the ways that when we do look back in 50 or 100 years, we can say we were responsible for building that infrastructure and we did it right. And that's one of the primary drivers you'll see at Microsoft and what we call responsible cloud. So if you're not familiar with the data center, it's not very interesting, to be honest. This is what your typical data center looks like, a whole lot of boxes and a lot of pipes on the outside. They're generally placed in flat areas that have access to hydroelectric power or typically low-cost power, where large companies can get land for pretty cheap and frankly can get some good tax breaks. And there's a lot of conversation around the impact of a data center on the local economy, but from a tax revenue perspective, they do generate a lot of revenue and pretty significant number of high-tech jobs in those spaces. And interestingly, when I was when I was before I even joined Microsoft, when I was thinking about data centers in my non-technical role, I always thought of, why can't we just put data centers up in the middle of the Rocky Mountains and open windows up to cool them? Because, as you know, cooling is a major energy user at data centers. And this whole issue of latency, which you're probably all very familiar with, but which was new to me, was the need for these data centers to be located close to their customer bases. And the two primary drivers for that for Microsoft and a number of other cloud computing companies, if you're not familiar with latency, it's essentially the time it takes for signal back and forth. Your mission data doesn't need to go to CLB light, even light of different industries like the financial industry. And interestingly, game industry is a primary driver of the industry. It's essentially just rack and rack servers. Most need servers about every 3 because of technology innovation. The fact it's working so hard, you burn them, but the primary cost of a data center is the racks that go into it. Also, energy for the water we use in these data centers to cool them, but there have been in a closet somewhere. Moving from those to a cloud computing provider actually reduces your energy use between 30 and 90%. The good thing is it also helps those companies match their server capacity with demand, and you can fluctuate that in a meaningful way. So you don't have to go out and buy servers that you may never use. You can increase and decrease your demand based on frankly, a subscription model if you choose technologies and software to help really manage our load in a significant way that reduces that overall energy use and makes it much more efficient for our customers. So when we talk about energy and we talk about water, moving to the cloud is actually a good thing, even though we've seen a pretty significant movement of energy usage from cloud computing and from data centers en masse. And then from a strictly computing perspective, we've had partnerships with a number of cities and entities out there that have really shown that shifting a lot of their compute to the cloud has been a huge tool for them in lowering their actual use in their operations. Cities are a great example of that, and I point cities out because it's such a stark example, but there are success stories all over the world where cities have utilized our software and utilized, frankly, not just our software, but a lot of different software opportunities out there in the cloud that have really allowed them to significantly reduce the operational load of their cities and their limits. And it's true for the private sector as well. But the projections are really great. And as we look from where we're at today to 2040 and beyond, this is obviously not a quantitative metric, but the size, the footprint of data centers around the world continues to grow, and the demand continues to grow. And it's not just cloud computing, but it's every application out there, whether it be Google or Amazon service, web internal energy commitments, which you can readily find publicly available. Our use as a company, the first is to improve our energy mix, and simply put, it's how do we move to lower and lower carbon sources of energy over time. And the second is really maintaining our carbon neutrality as a company. We've been carbon neutral for a number of years now, and we generally do that through the purchase of offsets and the purchase of renewable energy credits for our data centers, in addition to power purchasing agreements and other renewable energy deals. Our data centers, frankly, account for almost 70% of our total company's environmental or energy footprint, and the other 30% comes from a number of office buildings we operate around the world. One thing we do that's relatively unique is we choose to retire all the green attributes from our projects when we invest in renewable energy. And the reason that's an important point is to have a significant understatement. The renewable energy market is really confusing for the layperson, and frankly, it's very confusing for the experts as well in what counts, what's additional, what the assets are for different types of energy, and the financial mechanisms we use to buy and sell these renewable energy markets. And one key, I would say, challenges that companies face when they're choosing whether or not to invest additional dollars in renewable energy, because it really is just an ad cost today, to give you volatility reduction. But when we look at the bottom line cost of investing in renewables today, a lot of companies choose higher the renewable energy credits that they get from their purchasing that, whether or not that we consider that a valid use of renewable credits or not, but we just choose not to do that just to keep the process simple. So if we buy one REC from wind energy or one REC from solar, we automatically retire that. And then one of the fun parts we really get to do as a company is significant amount of R&D and testing and investment in new energy technologies. And frankly, that's one of the reasons that I chose to come to Microsoft was its ability to look well over the horizon and look at brand new technologies out there around storage and around super efficient servers, and just really looking at and investing and putting our money where our mouth is on what's the next evolution of the technology out there that's going to help us leap forward, not just from an energy efficiency perspective, but also from a compute perspective, and frankly, helping society move forward in these important issues around tackling climate change and other environmental challenges. And then finally, we are a company that really supports public policy in the space. And I know a lot of companies often sit on the sideline when it comes to environmental policy, but again, one of the drivers that brought me to this company from Starbucks, which was frankly also very active in public policy around climate and energy, was the fact that they use their muscle as a global technology company to follow his direction. We're at right around 44% mix of solar, wind, and hydro. Goal to slowly move, or quickly, hopefully move beyond that 44% to 50% next year, 60% in the early 2020s, and then finally get to 100% in the longer term. And again, what this is really doing is moving our grid mix that we purchase from the grid or that we purchase through agreements to more combination of solar, wind, and hydro. And there's a bit of a controversy there among the industry as how you define renewable energy. And if you want to get into that during the discussion afterwards, I would love to dive into that a bit as well, because frankly, there's not good agreement on how we ought to, as a standard, define what renewable energy is. And it seems a bit ironic, but all these debates over additionality, significant debates on whether or not we ought to, quote, count hydro in the renewable mix, and whether or not we ought to count vintage wind RECs, and things like that in the part of the mix of renewables. That's an ongoing debate within our industry. And what it's caused, unfortunately, is that different companies define renewable in different ways. And so it makes it a challenge to do apples comparison between one company to another when they say, what is your mix of renewable energy? Currently, the government has a way of defining that, but there are, again, like I said, that's in debate. So the way we define it is solar, wind, and hydro, and you can see our targets on the left there, and you can see how those targets compare to the grid mix in other countries today, where the U.S. is on the lower end there, and Sweden, Sweden is on the top. And then from a social standpoint, I would say that we don't necessarily define success as getting ourselves to 100% renewable in that space. The real definer for success, frankly, in companies that have made a commitment to have a positive impact on the public is how can we actually influence and improve the mix of renewable energy on the grid for everyone. And that's a key differentiator, and it feels nuanced, but it's a really key differentiator, because I would say version 1 of the renewable energy conversation were companies looking inwardly and saying, how can I, as a company, myself to 100% so I can either differentiate myself from my competitors, or how I can really take that volatility out of my energy supply mix by getting into long-term agreements, or just meet the social requirements and the social standing of my company. But the focus outwardly is saying, how can we as companies stakeholders in the market and influence the market itself in a way that allows us to completely push the energy, the energy grid itself, and that way companies don't necessarily have 20 people on their Microsoft, and there's those are frankly the kind of deals we're looking for in the future, are ones that have that additionality, but also create this partnership between governments, utilities, and the private sector. And a bit of a summary, but if you look at whether it be your wind or solar, is its intermittency, and the simple fact that the sun's not always shining and wind's not always blowing. And so we have to create this redundancy in the systems and on the grid to make up for that intermittency. And if we are investing in pretty significant, I would say, revolutions in the storage sector right now, where if we can, in an economic and effective way, find ways to store that renewable energy, then we can start really ramping down the amount of fossil fuel generation that we have to put on the grid to meet our peak demands and to meet our base demands, instead of this being that intermittent source of fuel for us. So that's critical for us, and frankly, that's where a lot of the fun is happening. We have a significant partnership with the University of Texas and a number of battery providers on flow batteries, which is a cool technology that you can scale up to any size. There's crazy technologies out there. I was just at a conference a couple weeks ago, and this guy was talking about how he's using rocks for batteries, and he essentially puts a whole lot of rocks together and he heats them up in the daytime when the power is cheap using hot water, and then he uses the latent heat coming out of those rocks to create seasoned professionals or people coming straight out of college. Is a storage revolution that's happening now. The smart grid, again, where we have the ability to create two-way flows of energy and use both our software and our giant band supply is critical for that space. Thank you at Penn State to contribute to that conversation. And then this will be my final slide, but this focus I mentioned on policy is critical. And as I said, a lot of companies hesitate to get involved in policy because of the controversial nature of it. And what better timing to talk about the controversial nature of government? But the impact that policy has on scaling up what companies are doing today, what the NGO space is pushing today, and what individuals are doing today cannot be overlooked. And when we look at the opportunity to increase access to clean renewable energy, to jumpstart new renewable energy projects, and clean technology, it's critical that policy is well, and that so here in Apple favors to the presidency of Penn. And it's not because we're green companies, but it's because we see the ability to create a much more stable grid in the future at a lower cost for us. So that combination, I think, of both environmental efficacy but also business acumen is critical to help companies like us make the business case to policymakers, whether they be conservative liberals or everywhere in between. So also very involved in the policy conversation, and I can definitely talk about that as well. So as I mentioned, that's the end, and I did want to keep it wide open for questions and keep my presentation short. And again, Mark and everyone else, I thank you for inviting me to participate. Wish I could be there in person, but I'm not going to be out to Pennsylvania until tomorrow afternoon. But any questions?
Yeah, Jim, thanks again for joining us. Appreciate you taking the time. Yeah.
I'm Veronica, a PhD student here, also taking the course. And I was wondering actually about the first part of the presentation where you were talking about the fourth industrial revolution. To be frank, come from sciences where there we don't really hear about the fourth industrial revolution, rather talk about the new slow green revolution, which is rather quitting technology and energy. Where I come from, or like where I studied in Freiburg, many of my friends, they quit Facebook. They not buy anything from this cannot be real. I was wondering whether you had numbers, for example, technology, energy used by I was wondering whether the component used energy
Technologies were replacing the question comes, what is the value of computing in itself? Because you have to make I would say, a professional and a personal determination on whether or not social media or cloud computing adds any value to your life for the energy footprint that's associated with it and the environmental footprint that's associated with it. And I'll tell a personal story, that helped make the case for me. When I was considering joining Microsoft, I was very happy at this amazing company started for a long time, and the progress of that company. And I was in limbo. I'd already had the job offer, and I was all the benefits and all the different things, and I wasn't giving them an answer yet. But I was surfing on the web just for Microsoft cloud computing, and this video popped up of this professor at, I think he's at Rutgers, but he's a cancer researcher, and he essentially said, look, we're working with the human genome to cure the human genome, to map one sequence of the human genome. And he said, today, 5 minutes, I talk to the cloud, and then I can share that with the world. And this is good. Cure cancer because the cloud, and see the with we
about the cloud service they're using.
Mm-hmm.
And just out of curiosity, do you feel that most IT companies are moving towards this? And would these companies be able to maybe come together to help other companies and be able to share what you're exactly doing within your companies to, improve the world, as you said before, is one of your, goals?
Yeah, absolutely. So the answer to your first question is yes. We are coming together, and there are a number of working groups that work pre-competitively, essentially, to work on both standards of how we ought to be measuring ourselves and sharing of efficiency and technology. It's and look
um, something along the lines of software management for communities. We're trying to do similar things. So what is the status of being able to predict that demand and usage and power requirements? My second question was just if you could clarify your comment about not sorry, I'm looking for the notes that I made. The carbon offsets, you said not renewing the green.
Yeah.
So if you could just comment on that as well.
Yeah. It's on your first question, predicting demand is critical. Data centers are beyond, and so demand prediction is critical for us. And then, you know, it gives us the ability to negotiate much better utility contracts the longer lead time we have. So if we go to utility and say we need 100 megawatts in a month, we're going to get it at market rates. But if we go to utility and say we're going to need 100 megawatts in 3 years, we can lower that cost. That's not being clear on that, but the renewable energy credit market is how companies have traditionally purchased their green attributes of their power. Renewable energy credits is often with on-site generation, where you may be putting solar panels right up on your sites, or wind turbines on your physical locations, or power purchasing agreements for solar farms where you're actually directly financing the construction of a new farm. And with current market conditions, solar power and solar RECs are much more expensive than what we call vintage wind RECs. So wind RECs coming from old solar or from old wind turbines. And often what you see are companies, in order to meet financing hurdle rates, they will finance a power purchasing agreement for 100 megawatts of solar power in a certain location, and then they will sell those solar RECs, renewable energy credits, onto the open market at a high price, and then they'll repurchase cheap wind RECs at the same amount of megawatts, and then call themselves, declare themselves carbon neutral, or declare themselves 100% renewable. And we don't do that as a company. It's, I'm not going to call it a bait and switch, but essentially it's a financing mechanism that often individuals or often companies utilize to reduce the operating costs and the cost of their power purchasing agreements. And we just don't do that because we think the best way to move more and more renewables onto the grid is just to buy them and then what's called retire those RECs, so you don't resell them, they just go away and no one else can use them again.
Okay, so that puts more money onto the market, and also means that other people have to purchase their own credits.
Correct. And it frankly forces you to support industries that have a higher cost of construction. So the solar industry is a good example of that. Their RECs are more expensive because they have a higher construction cost to build solar panels per megawatt.
Right. Okay. Thank you very much.
So, Jim, two questions here. Maybe kind of a loop with any innovation that you're currently working on, but from your perspective, you were talking about the next evolution and what will help make the next, the big leap forward in technology, or pushing data centers forward, or even just becoming, less impactful on the environment. What, from your perspective, what do you see as the next evolutionary leap that we're going to make in this space? And then,
Well, I mentioned that, and it's be storage, and if you look at it, we're going to locate a data center in Nevada or something. we essentially have to go to the utility and say, I need, say, 100 places to get that, which is either off the market, or they have to shift up their demand a bit, or or they have to create new generation to meet those demands. And in addition, because the requirement for data center to be on 100% and up and running at 100%, we also have to build 100 megawatts of backup power at the data centers. And traditionally, it's been these generators, which obviously isn't the cleanest form of energy. We've been able to start shifting and testing natural gas generators. Traditionally, that's been a giant rack of lead acid batteries give you between power data center and grid, disaster on the grid or blackout. That gives you get to do internet power that, at least in our industry, in the near future and the midterm future.
Great, thank you. So we have a little bit more time left, so I wondered if you could give some of your comments on, you had mentioned the definition of renewable energy in your talk, and just wondered if you could speak a little more about that and maybe the definition from your perspective, or what for companies or
opinion. So that comment on that. Traditionally, the government and industry define renewable energy around the concept of additionality. So renewable energy is essentially quote count, and arguments on both sides issue of power. Frankly, the ecosystem impact hydropower has, the impact on marine fish, which is critical in my state, in Washington, and also the displacement when you actually put new hydropower in there. But hydropower, so hydropower that's been around for a while, impacts have already happened from an environmental perspective. Often those aren't counted when you're saying, here's my renewable energy intercore renewable grid mix. But we just, as an industry, need to make sure and ultimately get to a point where we're aligning is the driver, and we're moving more and more toward carbon-free power, and not worrying about these other definitions that often handcuff us, or frankly either promote or discourage investment in technologies, or promote or discourage companies from making those investments. So that's why I talk about renewable energy in the way I do. And this is just to keep on. That's big disaster right now because sectors purchasing so
back to preparing for your trip to